Question 3. Closest pair of points. This question is relatively hard, especially compared to the ones we discussed earlier. This question can be solved with many other ways, but we are going to solve it with the divide and conquer method. We are given an array of points. The question is, how do you find the closest pair in this array? Here's an example of an array of points. First, we sort the array according to its x-coordinates and find the middle point in the sorted array, which will be p n over 2, that is the point 5 and 8 in this case. Then we divide the array into two subarrays. First one containing points from p0 to pn over 2, and the second one containing points from pn over 2 to pn. Then find the smallest distances inside both subarrays recursively. Suppose they are dl and dr, and the minimum of them is d, using the Euclidean distance formula. Build an array named, let's say, picked, of all points whose x-coordinates is closer than d to the vertical line that passes through the middle point. And finally find the pair with the smallest distance inside the picked array and return it. It may sound like it would work in big O n squared, but it actually works in big O of n. Here's how. Every point inside the picked array can be considered to be in a box like this one. And because the maximum distance inside each smaller box is d over square root of 2, which is smaller than d, proves that each smaller box contains at most one point inside them. Otherwise, they would be closer than the distance d, which contradicts with the result we had earlier. And if there is a point inside the box, the distance from a point outside the box and the point inside the box would be bigger than d. So for every point inside the picked array, there are at most 7 other points to compare. Hence, Tn equals T7n, then the Tn would be equal to big O of n.